So in today's lesson, we're going to finish up that last page of section 8.4. In this video, I'm going to talk a little bit about just things to make sure you know for the test on Tuesday. And then there'll be a second video where we'll start the chapter 1 notes. So we were talking about comparing similar objects. And so remember that similar objects have proportional dimensions, not the exact same dimensions, but proportional dimensions. And so if you want to find out if an object is similar, just like we did with these triangles and these cylinders, is compare all the dimensions that you're given, and if they have a similar proportion or a similar ratio, then they are similar. So let's look at the spheres. And so it says compare the objects and determine if they are similar. And so we have to look at what we're given here, and we're given diameter. And so we have to remember that diameter is the distance across the circle. And that radius equals half of the diameter. So here we're given the diameter and the diameter, and that should go all the way to the edge. Okay, and so since all we're given is the diameter for each of these spheres, we just have to compare the spheres to each other. That's all we can do right now. So if we compare sphere 1 to sphere 2, we get 4.3 centimeters over 6.1 centimeters, and that gives us 0.705. Now, this doesn't really tell us anything, and we're only given one dimension, so we can't compare it to anything. And this is because of the rule stating that all spheres are similar. Okay, so anytime you see a question with two spheres and you're asked, are they similar? The answer is yes. And this is because when we compare spheres, we only have one dimension to compare. And since you can't make that comparison, we say that they're similar. Also, it's just a function of the shape of a sphere and how a sphere is constructed, and how there's really only one way to construct a sphere. Whereas think of a triangle or a polygon of some sort, there's lots of ways you can put lines together, but with a sphere there's only one way. So all spheres are similar, but let's look at the following two boxes. So we're told they're similar, and because we're told they're similar, we can determine the height of box 2 by using what we know about the ratios. So we'll say this is height, here's our length, and here's our width over here. And then what we're looking for here is height. So height will equal x, and we don't know what that is. And then length will equal 9.2. And then this is our width over here. So what we have to do is find the ratio, and we can choose either of the dimensions we know. So we know length and width, so we can compare either length or width. And I'm going to compare length, but you'll see if you do it yourself, you can compare width on your own just to see. So we're going to find the ratio that makes them similar. So we know they're similar, so we just want to find that ratio. So we do box 1 over box 2, and we'll do length over length. So length of 1 over length of 2. So we have 23 centimeters over 9.2 centimeters. And if you do that on your calculator, you'll find that you get a ratio of 2.5. So that means that the dimensions of box 1 are 2.5 times. Now, is box 1 bigger or smaller than box 2? Hopefully you can see that it is bigger. So the dimensions of box 1 are 2.5 times bigger than box 2. And so that means that if we want to find the dimensions of box 2, so we want to find height of box 2, so we have to take height of box 1, and what are we going to do? Divide or multiply by 2.5. And keeping in mind that we want to go from a bigger number to a smaller number because the box 1 is bigger than box 2. So we're going to divide by 2.5. And we have 18 divided by 2.5, and that gives us 7.2 centimeters. And that's the height of box 2. And you can go back and look at your boxes and see, does that sort of make sense if this is 7.2 centimeters? And it looks pretty proportional to the rest. And so, I mean, if you had gotten, say, a height of 24 centimeters, then hopefully you'd see that that's not correct because box 2 is smaller than box 1. So if you had multiplied 18 by 2.5 instead. And I talked to some of you about this in class on Tuesday. The nice thing about this unit is usually the answer is obvious if you're wrong. So if you're not sure if you should enlarge or reduce it or multiply or divide it, do both. And then if you look and you say, okay, well, I was asked to enlarge it and the number I got was smaller because maybe you divided, try multiplying, and then you'll be able to see where you went wrong. So you have the textbook questions here, and then that's the end of chapter 8, which is unit 4. So things to keep in mind for this unit. So we started with rate, and rate is a good thing. So make sure you can do rate, and remember that rate is change in amount over change in time. Okay, and that's the generic rate. Of course, when we were doing dollars per pound or dollars per kilogram or all that kind of stuff, liters per minute, well, that one works as a rate. Sometimes rates are different, but in general, it's a change in amount over change in time. And so just remember to include your units in that all the time. So if it's a cost per unit, so let's say dollars per kilogram, make sure in your answer you put $2 per kilogram. Okay, so include that dollar sign because the units are really important here. And anytime we want to convert, the general formula we have for that is want equals have times no. So want being what you are looking for, have is what's provided in the question, and then no are the known conversion factors. So usually you'll find them on that conversion factor sheet, but sometimes the question will tell you, like we know Shannon can walk 2 kilometers an hour, how far does she walk in 3 hours, or something like that. So sometimes the no is in the question. Okay, and the other thing to remember about the no's is that 60 seconds per minute, per 1 minute, is the same as 1 minute per 60 seconds. Okay, so please remember to flip if you need to. So always look at what you want unit-wise at the end, and remember that we have to cancel out. Okay, so like in the quiz, you were given kilometers per hour and also kilometers in distance, and you wanted hours. So what you had to do was flip this and make it into hours per kilometer, multiply that by the distance you were given, and you end up with hours. Okay, so don't be scared to flip it. It's the same thing. The next thing we talked about with rate were slopes. And so we have, remember, a linear or a nonlinear. So linear would be up or down, and then nonlinear would be some variation of a curve. Okay, and remember that if you're at the top of the hill, if you're standing at the top of the line and you walk down, your slope is negative. And if you're walking up, then your slope is positive. And if you have one of these slopes, these curvy slopes, that means you'd take an average to get the slope. Okay, now, what if you had a slope with a line that looked like this? without knowing anything, without knowing what the graph is measuring or what the graph is indicating, I know that this slope is what? This slope equals 0. And this is a function of how we find slope. Slope is rise over run. This line, this straight line, is not rising at all. So it's going to be 0 over whatever number. And it doesn't matter how long it goes. It could go for 1,000,000 kilometers. It's still no rise, so it has no slope. Okay? And then when you're given a graph, or a graph like we were given in one of the worksheets, you can figure out the slope at each interval, and so you'd find it in meters per second or kilometers per hour at each part, and then you can say where the person is moving the fastest or the slowest, or whatever the question's asking you. The third section in this unit was scale diagrams, and so remember that we can either have a reduction or an enlargement in terms of scale diagrams. We work with ratios, and so you'd have a 1 to whatever ratio, 1 to 20, and it would be diagram to actual. So you can work with a ratio, and remember that ratios and scale factors, neither of them will have a unit, or you can do a scale factor. So this is a ratio, you have a scale factor of diagram or photo over actual. Okay, and your scale factor, you can sometimes bring it down to a fraction. If your scale factor does not divide into an even fraction, so if your scale factor is 1 over 2, so it's 0.5, then, sorry, decimal, then you're fine. But if it's going to be a decimal like 1.33333, just keep it as the fraction to be as accurate as possible. And when we're working with scale factor, try to be in lowest terms possible. And then you can use the scale factor to move back and forth between them. Okay, so if you know your scale factor and your diagram, you can rearrange to find actual. Okay, so this is an equation just like every other equation we've been working with, and you can rearrange to find it, to find a missing part. And then the other thing to remember is that when we work with scale factors, we can express them as percents. So if you want to go from a percent, and let's do 60%. So from a percent to a number, and this is a good thing to remember, you will divide by 100, and you end up with 0.6. So 0.6 is the number you're looking for. And to go from a number, so these are both for scale factor, a number to a percent. And so let's say that we had 2, you would multiply by 100. And then 2 times 100, so this would be at 200%. Okay, so if you're given a number and I want you to find me percent, multiply by 100. If you're given percent, divide by 100, and then you'll get the number and you can work with that. And then in general, if your scale factor is less than 1, it's a reduction, and if it's greater than 1, it's an enlargement. And then the last section that we worked on was the similar objects, and that's the one that we just did. So again, remember, if I ask you to find out if an object is similar, find the ratio of each dimension you're given. So if you're given 8 dimensions, if you're given some weird shape that looks like this, okay, and you're given 2 of them, and I ask you, are these similar? You have to do the dimension for each side that you're given. If the ratios are similar, or if the ratios are the same, they are similar. If the ratios are different, they are not similar. Okay, so work through the review package. I will be posting the bonus quiz later today, so make sure you get that off before Saturday morning. And email me if you have any questions at all, or come see me Monday. And there's going to be one more video, and have a great weekend.